Welcome to The Explainer. Today, we are going on an incredible journey. We're going to follow a single copper atom, all the way from being locked deep inside a piece of rock to becoming the 99.99% pure metal that's absolutely essential for, well, pretty much everything. Your phone, the power grid, you name it. So, let's get into it.
I mean, really think about that for a second. How do you go from a simple rock, something you could just pick up off the ground, to the 99.99% pure copper that's inside your phone? We're talking about a metal so pure it carries the electricity and the data that basically defines our modern age. So, how on earth does that actually happen?
Well, the answer is this incredible journey that's part brute force and, honestly, part chemical magic. It's all about chemistry, acid, and electricity. We're going to follow our little copper atom on its adventure through these massive acid baths, super smart chemical sorting machines, and some pretty intense electric transformations.
Okay, so first things first. Before you can do anything fancy with the copper, you've got to get it out of the rock it's been trapped in for, millions of years. This is step one, the Great Escape, liberating that copper from stone.
And this whole thing starts big. We're talking about massive open-pit mines, where the copper-bearing ore gets blasted right out of the earth. Then, all that rock is crushed down into smaller, much more manageable pieces. The analogy is pretty simple, right? You gotta break open the treasure chest to get to the treasure inside. And then the crushed ore gets mixed with a bit of acid just to get it ready for what's coming next.
All right, now for the first really cool bit of chemistry. This is called heap leaching. You take those giant piles of crushed ore, literally called heaps, and you give them a slow, steady acid bath. A weak sulfuric acid solution is dripped over the top, and it just slowly trickles all the way down through the pile. Now, the point here isn't to melt the rock or anything. Think of the acid like a very specific chemical key. Its only job is to unlock the copper from the other minerals it's stuck to.
So as that acid seeps down, it does its job. It dissolves the copper out of the rock, and what trickles out the bottom is this blue-tinted copper-rich liquid. And it has a great name. It's called pregnant leach solution, or PLS. Why? Because it is literally pregnant with dissolved copper ions. Our little copper atom is finally free from the stone. It's now swimming in this liquid.
But here's the catch. Our copper atom is free, but it's not alone, and it's not very concentrated. We're only talking about 1 to 6 grams of copper for every single liter of this solution, so it's super dilute. Plus, it's mixed in as a whole bunch of other stuff that dissolved out of the rock that we just don't want. So that's the next big problem to solve. How do we get just the copper, and how do we get a lot more of it in one place? And this brings us to what I think is the most clever part of this whole process. If the last step was about freeing the copper, this next phase is all about purification. We're talking about a high-tech chemical sorting machine that separates the best from the rest.
Okay, but before we get to the really high-tech part, there's a quick housekeeping step. The solution gets pumped into these big settling pods, basically just to let any leftover sand or dirt or whatever fall to the bottom. You need a really clean liquid for the delicate chemistry that's about to happen.
All right, to get what happens next, let's use an analogy. Imagine that pregnant leach solution, the PLS, is a huge, crowded party. The copper ions are the VIPs we want, but they're totally lost in a crowd of other unwanted elements, all these impurities. Now, we introduce something new, an organic solvent. And this solvent is like a fleet of VIP limos sent to the party. The limos contain a special chemical, an extractant, that's like a chauffeur with a very specific list. Their only job is to find the copper VIPs, pick them up, and completely ignore everybody else.
So, just to remind you, let's look at the numbers. The PLS, our crowded party, started with a copper concentration of just 1 to 6 grams per liter. Pretty dilute, not very VIP at all. But check this out. After our chemical limos have done their job, picking up all the copper and moving it to a new, clean solution, the concentration absolutely skyrockets. We're now at 35 to 45 grams per liter. That is a massive jump. We've ditched all the junk, and now we have a super concentrated, super pure, copper-rich liquid.
So, let's take stock. We've freed the copper from the rock. We've purified it, but it's still dissolved in a liquid. So we need one last, final transformation. This is the grand finale, where we use electricity to turn that dissolved copper back into a solid, pure metal. This last step is called electrowinning, and you can think of it as basically running the whole process in reverse, powered by a whole lot of electricity. Here's how it works. You stick 2 different metal plates into our purified copper solution. One's an anode, one's a cathode. Then, you run an electric current through the whole thing.
The positively charged copper ions, well, they're naturally drawn to the negatively charged cathode. And as they reach it, they plate onto its surface, atom by atom, turning back into pure solid copper metal.
And the result of this? Over a few days, you literally build up these thick sheets of solid copper. And the purity is just incredible. We're talking 99.99% pure. Now, that's not just a random number. That's a specific, globally recognized benchmark called LME grade, which means it meets the quality standards for the London Metal Exchange. This is the good stuff, the copper that industry trusts and relies on.
So there we have it, these huge, beautiful sheets of ultra-pure copper. But the journey for our copper atom isn't quite done yet. Now it has to go from the plant and find its way into your everyday life.
So let's just do a quick recap of the entire journey. It starts with mining and crushing. That's the brute force. Then comes leaching, using acid to dissolve the copper. Then the really clever part, solvent extraction to purify and concentrate it. And finally, electrowinning, using electricity to plate it into a pure metal. From there, it's ready to enter the global supply chain.
So where does all this amazing copper go next? Well, these big sheets, called cathodes, are melted down and they become the fundamental building blocks of our modern world. They get turned into rods for pretty much all of our electrical wiring. They become the tubes and pipes for plumbing and air conditioning. They're made into those super thin foils you find on every circuit board. And of course, they're used to make alloys like brass and bronze. It's amazing, right? From one simple rock, the whole world gets wired.
You know, this whole process, from a chunk of ore to a piece of wire, is just a triumph of chemistry and engineering that's been perfected over decades. It really makes you think, though, doesn't it? This is how we power our world today. But as our needs change, what new chemistry, what new amazing processes will we need to invent for tomorrow?